So today we're going to be talking about zeros, and we're going to be talking about them in two different ways. We're going to be talking about them graphically and algebraically. So let's talk about graphically first. All that means is, what does a zero look like on a graph? That's what we're saying here. What does a zero look like on a graph? So on a graph, zeros are the points at which the graph crosses the x-axis. And I'm going to say crosses or intersects. Intersects is another word for crosses, but usually in math we use the word intersects. The x-axis. Okay. So the points at which the graph crosses or intersects the x-axis. Okay, so let's kind of take a look here at Desmos. So if we're looking at this graph is x equals, or x minus 2, x minus 2. So on the left-hand side you can see x minus 2 is what this graph looks like. So where do you see a zero? Where do you see a zero? Well, if I put my cursor over that, do you see how it's 2, 0? That's where it crosses the x-axis, right? So wherever it crosses the x-axis, that is whatever your x is at that point. And what is my x at this point? My x is 2 when my y is 0. So the point at which it crosses the x-axis is at 2. If we look at a different one, let's look here. This actually crosses it twice, right? So if I look at this graph, it crosses it here. So when x equals 1, it crosses it. It also crosses it when x equals -1. We don't look at the y's, we're only talking about the x's. That's when the graph crosses the x-axis, is whatever the x is. So 1 and -1 for this one, 2 for this one. Okay, we're going to do tons of examples on this, but I just wanted to show you that a little bit first. So another thing, algebraically, that's another way we talk about zeros. And algebraically is just the points at which f of x equals 0, or you could say y equals 0. Remember, those are the same thing. F of x here, f of x, and y, they're the same thing. So at which y equals 0, or f of x equals 0. And that makes sense, right? Because if we go back here, didn't y equal 0 when x equals 2? Y is 0 there, right? And didn't y equal 0 when x was 1? And y equals 0 when x is -1, right? So in the same way, we can actually solve that algebraically. Just means with algebra. Solve it with algebra. Okay, so what are they also called? What are zeros also called? There's a few different names for zeros. There's a few different names. So they're also called roots. So if I said find the roots, that means find the x-intercepts. Okay, or find the zeros. I'm sorry, I just went ahead. The next one is x-intercepts. So if I say find the x-intercepts, that means find the zeros. If I say find the roots, that means find the zeros. Okay. I can also say solutions. So there's quite a few different ways that we can say what are the zeros of this function. Okay. So let's look at the graph first. We're going to identify the zeros by looking at a graph. That's the first thing we're going to do. So let's look at number 1 here. Where does it cross the x-axis? This is actually the exact same line on Desmos. Here, because it crosses this. It crosses this at 2. So our answer here is x equals 2. Wherever it crosses the x-axis, that's your answer. That's your zero of the function. Okay. What about on 2? Now again, we're only looking at the x-axis. So we're looking here and we're looking here. That's it. We're only looking at our x-axis. Okay. Okay, so what is the 0 here? So the 0 here, 1, 2, so this is a -2, right? We're going over -1, -2. So that's a negative 2. So I'm going to write x equals, now when we list more than one point, we're going to do that funny little bracket thing, and we're going to say negative 2. Now, we always start at 0, 0. What is this one? That's a 1, right? So our two zeros are negative 2 and 1. Okay, where does it cross here? Looks like it crosses right there. So where does it cross for the x? 1, 2, 3. Our 0 of the function is x equals 3. All right, this one crosses twice. So this graph, it crosses here and it crosses here. So I don't know if you've seen these kind of functions before, like up here, that's a parabola. This right here, this is a parabola. Down here, you're going to be learning about these in Algebra 2. This is absolute value graph. So x equals, now where do we see the first 0? 1, 2, 3, 4, negative 4. Remember when we go to the left, it's always negative. Since we're doing more than one point, we're going to do the brackets. And then if we go to the next 0, that's going to be at 1. So negative 4, comma 1. Those are our two zeros. Okay, another parabola. So that means we're going to have two different points, one here and one here. So my first x equals negative 1. So negative 1. My second x, my second 0, 1, 2, 3, 4, 5, my second root, remember I can call it a root as well, is 5. Okay, how many roots or how many solutions, how many zeros, there's so many different ways to say it, do I have for this function? Well, I have 1 here, 1 here, and 1 here. What does x equal here at this root? 1, 2, 3, 4, 5. So x equals 5. Negative 5, I'm sorry. We're going to the left, so that's negative direction for x. What does x equal here? It's right at the origin, so it's 0. And on our next point, we're going to the right, so it's positive 3. All right, cool. So that one actually had 3 different zeros. So if we turn it over to the back, now it says identifying zeros algebraically. So remember at the beginning of our notes, we could do it graphically. We could find zeros graphically, and that's what we just did down here. We looked at the graph over here, and we identified the zeros. We can also do it algebraically. So what does it mean to do it algebraically? It means the points at which f of x equals 0, or remember f of x is the same thing as y equals 0. Okay? So algebraically, it says the points at which y equals 0 or f of x equals 0. So we're going to plug in 0 for y because it says right here, when y equals 0, that's another way to find the function, the 0 of the function. So we're going to plug in 0 for y. Okay, so where is my y? Well, my y is here. This is f of x, right? F of x is the same thing as y. So we're going to write 0 equals, and actually, before I do that, let's do step 1 here. Step 1 is set the function and you remember what a function is? A function only has one x value for every y, one input for every output. So remember when we did the vertical line test, it cannot hit your pencil more than once, or it's not a function. So set the function equal to 0. That's the first step. So that's what we just did, right? Up here, we said 0 equals. We set the function equal to 0. So I'm going to continue with this, 4x minus 8. All I did was set the function equal to 0. Now step 2, solve for x. Solve for x. Okay. So this is just like solving an equation. What are we going to do? Which two are like? We have a 0, we have a 4x, and we have a negative 8. 0 and negative 8 are like terms. So how do I get the 8 to the other side? I add 8. Always do the opposite when we're crossing the equal sign. So 8 equals 4x. That goes away. Now divide each side by 4. So x equals 2. 2 equals x, or x equals 2. All right, let's try this one. So in this case, remember we always, the first step, set the function equal to 0 and then solve for x. So we're going to set the function equal to 0 so we can find our roots, or our zeros of the function. Okay, so I'm going to subtract 2 from both sides. Negative 2 equals 2x, and then to get x alone, divide by 2. So negative 1. So x equals negative 1, or negative 1 equals x. Same thing when you have an equal sign. Okay, first step, set the function equal to 0. And then we're going to solve for x. So 0 equals negative x plus 7. So I'm going to subtract 7 from both sides. So negative 7 equals negative x. Now I can't have a negative x. There's a negative 1 right here. It's like an imaginary 1. So we're going to divide by negative 1 to both sides. So x equals negative divided by negative is a positive 7. Okay, now this one we have another fraction, our favorite thing to do. So let's figure this part out. 2/3 x minus 6. So for this one, we're going to add 6 to both sides first, right? Add 6. Add 6, because we know the 0 and the 6 have to go together. 6 equals 2/3 x. Okay, how do we get rid of, I'm going to rewrite this up here. How do we get rid of a fraction? When we have just a fraction next to a variable, we multiply by the reciprocal, 3/2, right? The flip. Remember we flipped the fraction, that's what reciprocal means. We're going to multiply. Now, here, the 2's cancel, and 3's cancel. So what are we just left with on this side? We're just left with x. Now let's put this over 1. Remember, whenever we're multiplying a whole number, we put it over 1 to multiply across for a fraction. So here we have 3 times 6, so that's 18, and then over 2 times 1, which is 2. So it's going to be 18 over 2, which is 9. 18 divided by 2 is 9, so x equals 9, or 9 equals x. Okay, just 2 more, and then we're gonna do a couple on Desmos. So remember, the first step here is set the function equal to 0. We're gonna subtract 2. We want to get that 1/2 x all alone. Negative 2 equals 1/2 x. Actually, I don't know why I wrote the fraction like that. Don't write the fraction like that. It makes it harder when you multiply. Always just put 1 over 2 like that. Make it a straight line instead of a crooked line. Okay, now we're going to multiply each side just like we did up here. Just like we did up here when we multiplied by the flip, or the reciprocal of the fraction. We're going to multiply this by 2 over 1. That's the reciprocal of the fraction. Now these cancel, and we're just left with x. I'm going to rewrite it over here. So x equals, now what's this part over here? Well, I can put that negative 2 over 1. So negative 2 times negative 2 is negative 4. Negative 4, and then a 1 on the bottom. 1 times 1 is 1. So x equals negative 4 over 1, or negative 4. Okay, one more fraction. It's good to practice. So 0 equals, remember we're always setting our function equal to 0 to find the roots, plus 4. So we're going to subtract 4 from both sides. That cancels. Negative 4 equals 2/5 x. Oh, negative 2/5 x. So to get rid of the fraction, we're going to multiply by the reciprocal. Multiply by the flip of the fraction, which is 5 over negative 2. This cancels. This cancels. I have x left on by itself on one side of the equation, and then I'm going to put this over 1 to multiply fractions. So now I'm going to be multiplying across. 5 times negative 4 is negative 20 over negative 2 times 1 is negative 2. Negative 20 divided by negative 2 is positive 10. All right, now I want you guys to open up a new tab, and you're going to go to Desmos. So here, we're not using a graphing calculator, okay? So we're going to say using Desmos. So we're not going to be doing this. We're going to be using Desmos. So let's use Desmos. So let's go on a new tab. Oh, and I'm going to plug in. I'm going to plug this in. X squared minus 16. Remember, this is the same thing as y. F of x is the same thing as y. So I'm going to type in y equals x squared minus 16. Okay, so this is, you're going to type into Google, you're going to type in Desmos. And then you're going to click on Start Graphing. So that big red button in the middle, click on Start Graphing. And I already forgot what I'm graphing. X squared minus 16. Okay, so you're going to write y equals, now the a, you see, okay, push x, and then you see that a squared term, click that, click the a squared, that's going to give you that squared, okay, and then minus 16. There you go. Now, if you click with your mouse on this right there and on this right there, those will come up, so you'll be able to see the x's. So what's my x on the left? One of my x's is negative 4, and one of my x's is positive 4. So here we can write x equals that little curvy bracket because we have more than one answer, negative 4 and 4. And don't we love Desmos? Because you wouldn't want to have to figure this out, set that equal to 0, right? So this is a better way to do that, especially even in higher math classes when you do have to graph these. You can check on Desmos, and you can check graphing with any line on Desmos, so it's really nice. It's a good way to check. Okay, let's type this in. So 5x squared plus 5x minus 30. So I'm gonna push, see the x on the right, I'm gonna push this x to get rid of that, and I'm gonna type in my new graph. Remember, f of x is the same thing as y. Y equals 5x. Now type the a squared for the squared button. If you have any questions, please raise your hand and I'll come around and help you, okay? Now, put your mouse over the gray circle that you see and it'll come up. So you'll be able to see that that's negative 3 and 2. So what are my zeros of this function? Negative 3 and 2. Always least to greatest. Next one. Y equals negative x squared minus 2x plus 24. Again, put your cursor right over the 2 points that hit the x-axis. Those are your zeros. Those are your roots. So negative 6 and negative 4. X equals negative 6 and positive 4, I'm sorry. Negative 6 and positive 4, right? Yeah, positive 4. All right, number 16. Y equals x squared plus 7x minus 8. Okay, wherever your gray dots are, put your cursor over it. So it's negative 8 and 1. And notice, what is the y in this case? On all of these, the y is 0, right? That's why when we solved algebraically up here, we plugged in 0 every time we saw y, right? 0 for y here. We plugged in 0 for y. We plugged in 0 for every single time. And that's what we have to do. We have to set the function equal to 0. We have to make y equal 0 and then solve for x. And that makes sense when we're looking at Desmos, right? Because we're getting a number for x every single time, but we always have 0 for y. Whenever y is 0, those are your roots for your function. Those are your zeros for your function, okay? All right, so for number 16, can't draw with that. X equals -8 and 1.